March 15th, 2025, Southern Carpathians, Romania. 30 European bison stand inside transport crates on a frozen meadow near Retezat National Park, loaded off planes from Polish breeding centres, breathing cold mountain air for the first time in their lives. 30 animals, in 50 square kilometres of empty valley. The last wild bison in this landscape vanished in the early 1800s, a silence of 200 years. Conservation teams called this a founder herd. The honest math said it could collapse inside a single winter. Then, on March 15th, 2025, the crate doors opened. That's not what happened. What happened instead is still running through the data. Because within months, something in the mountains began to shift in ways the models hadn't predicted. Something that went far beyond 30 animals finding their footing in the snow. The question this story keeps circling back to is a simple one. What actually happens to a mountain when its lost animal finally comes home? I'm Dr. Henry Vale, and this is the full arc of one of the most improbable wildlife comebacks on the European continent. This is episode 3 of the series. Each episode follows a single, real rewilding intervention, from the moment the decision was made, through the release, all the way to what the long-term data now shows on the ground. No simulations, no projections, just what actually happened. The European bison, Bison bonasus, is the heaviest land animal on the continent. It once ranged from the British Isles to the Urals. By 1927, the entire wild population was gone, every last one. The species survived only because 54 individuals remained in captivity worldwide, 54 animals standing between a species and permanent erasure. This story begins with those 54, but it doesn't end with rescue. Rescue is the easy part to tell. The harder story, the one science is only beginning to catch up with, is what recovery does to a landscape once the animal is back inside it. How a forest that has been missing a keystone presence for 2 centuries starts, slowly, to remember what it was. That is what this episode is about, and the Carpathian data from 2025 is unlike anything the rewilding community expected. Nobody was paying attention to the bison back then. The last confirmed sighting in the Carpathian range had been filed away in a provincial record somewhere in the early 1800s, a footnote in a hunting ledger, the kind of entry that gets transcribed once and quietly forgotten. That was about to change. But to understand what the return of the bison meant, you first have to sit with what the absence cost. And the cost was not obvious. It did not announce itself. It accumulated the way debt accumulates, silently, in the background, compounding across seasons and decades until the landscape was carrying a weight it could no longer name. Picture the Carpathian forest in winter. Not the postcard version, the real thing. A grey-green tangle of beech and hornbeam on the lower ridges. The canopy closed so tightly that the forest floor sits in permanent dusk. The undergrowth is dense with hazel scrub and invasive blackthorn pushing into every gap. There are no clearings. The meadow corridors that once threaded between the tree lines have been swallowed. And the silence is the wrong kind. Not the quiet of a healthy forest resting, but the quiet of a system that has lost one of its primary voices. That voice was the European bison, the largest land mammal on the continent, and for most of the Carpathians' recorded ecological history, one of its most consequential architects. The hunting pressure that erased them was not a single event. It built across roughly 3 centuries. Aristocratic estates used bison as prestige quarry from the 1500s onward, and by the 1700s, the combination of organised drives, habitat loss from expanding timber operations, and repeated warfare across Central Europe had reduced the Carpathian population to a remnant. By the early 1800s, that remnant was gone. The last animals in the broader wild European population, a small group in Poland's Białowieża forest, survived only because the Russian Tsars placed them under imperial protection. When that protection collapsed during the First World War, soldiers on both sides hunted the remaining animals for food. The last wild European bison was shot in 1927. The species existed after that only in zoos. What the Carpathians lost when the bison disappeared was not simply a large animal. What they lost was a process. Bison are what ecologists call a keystone grazer. A keystone species is one whose influence on its environment is disproportionately large. Relative to its population size, remove it, and the structure of the system shifts in ways that cannot be explained by the animal's absence alone. Bison graze heavily on woody undergrowth. They push through dense scrub, breaking stems, opening gaps in the canopy. Their hooves disturb the soil surface, creating bare, churned ground where light-dependent plant species can germinate. Their dung deposits nitrogen and phosphorus directly into the soil, seeding fungal networks and accelerating decomposition cycles. A single adult bison, moving through a forest over the course of a year, performs a form of ecological maintenance that no other animal in the Carpathian system replicates. Without that maintenance, the forest began to close in on itself. Within decades of the bison's disappearance, invasive shrub species, primarily blackthorn and invasive hazel variants, began colonizing the open meadow corridors historically maintained by large grazer pressure. Those corridors were not decorative. They were functional connective tissue, the pathways through which deer moved between grazing grounds, wolf packs travelled between territories, and seed dispersal flowed across the mountain system. As the corridors closed, the connectivity of the ecosystem began to fragment. The cascade did not stop there. Red deer populations confined to denser forest cover declined in range and genetic diversity. Wolves, which depend on deer as their primary prey base, contracted their territories. Lynx, which hunt in the ecotone zones between forest and open ground, lost the edge habitat their hunting strategy requires. Each absence created conditions for the next. The system did not collapse dramatically. It diminished. Quietly, over 200 years, it became a lesser version of what it had been. Ecologists call this accumulation of lost ecological function ecological debt. The debt is measurable. It shows up in soil carbon levels, plant species diversity counts, canopy structural complexity, and the genetic bottlenecks visible in deer and wolf populations. By the time serious rewilding conversations began in the late 20th century, the Carpathian system had been running that debt for roughly 8 human generations. If you're wondering how that's even legal, so is everyone else. The fact that systematic ecological loss can occur across international borders, across centuries, with no formal accounting and no legal mechanism for restoration, is one of the reasons the modern rewilding movement exists at all. The science of ecological debt gave conservationists a framework for arguing that restoration was not a luxury or a sentiment. It was the correction of a quantifiable loss. The people who designed the 2025 release understood this framework in detail. They had spent years building the case that the Carpathians were not simply a beautiful mountain range that happened to lack bison. They were a damaged system waiting for a repair that only one animal could deliver. The accumulated soil nitrogen deficit alone, modelled from pre-absence baselines, represented decades of missing biological input. Shrub encroachment across former meadow corridors covered tens of thousands of hectares across the broader range. The genetic diversity of remaining wolf and lynx populations showed the statistical signatures of long-term isolation. The debt was not metaphorical. It was written into the chemistry of the ground and the DNA of the animals that remained. The hunters and loggers and armies of the 18th and 19th centuries had not known they were doing any of this. They were simply removing an animal that was in the way. The consequences arrived on a timescale that no individual human life could perceive, which is exactly why they were never held to account. The scientists of the 2020s could perceive them. They had the data, They had the baseline models. They had 2 centuries of absence to study, and what that study told them was that the moment you returned the bison, the landscape would begin to respond, not in years, but in months. The suppressed seed banks in the soil, the dormant fungal networks, the deer and wolf populations waiting at the edges of their compressed territories, all of it was primed. The system had not forgotten what it was. It had simply been waiting for the right signal. That accumulated debt would come back to haunt the ecosystem itself. But that's getting ahead of the story. The scene that stays with you, if you spend enough time in the project documentation, is not the release day. It is a photograph taken at a breeding centre in southern Poland in the winter of 2022. A bull bison stands in early morning light at the edge of a holding enclosure, breath rising in slow columns from his nostrils, his dark eyes fixed on something beyond the fence line. He weighs close to 900 kilograms. He has never stood on Carpathian soil, and yet the project team looking at this photograph knew, with a precision that bordered on the uncanny, exactly where he was going and what role he would play when he got there. That precision did not happen by accident. It was the product of years of institutional architecture, scientific planning, and a partnership between a private rewilding initiative and a national government that almost did not happen at all. The organisation at the centre of it was X-Force, operating under the formal designation of the X-Force Extreme Rewilding Initiative. X-Force had been active in large-scale ecosystem restoration across Europe and Central Asia for nearly a decade before the Carpathian project took shape. Their model was not the traditional conservation NGO model of lobbying and incremental policy change. It was direct intervention, identifying landscapes with measurable ecological debt, designing science-led reintroduction programs, funding the infrastructure, and partnering with national governments to create the legal and physical conditions for release. If that sounds like an unusually aggressive approach to conservation, keep watching. The project director was Marek Nowak, a Polish conservation biologist with a background in large mammal ecology and a reputation for pushing reintroduction timelines other scientists considered optimistic. Nowak had been involved in bison monitoring in the Białowieża region in the early 2000s, and he had spent years arguing that the Carpathians represented the most ecologically suitable and socially viable candidate for a significant bison reintroduction anywhere in Europe. The argument was not just about habitat suitability, it was about leverage, the idea that a successful Carpathian release, documented rigorously and in real time, could shift the entire European rewilding conversation in a way that smaller, quieter projects had failed to do. The partnership with the Romanian Ministry of Environment was the hinge on which everything turned. Without it, X-Force had science and funding, but no legal standing to operate inside Romanian territory, no access to the land corridors the release required, and no monitoring infrastructure. The negotiations took the better part of 3 years. They involved not just the national ministry, but regional authorities surrounding Retezat National Park, local landowners whose properties sat within the proposed movement corridors, and legal teams on both sides working through frameworks governing animal welfare, liability, and land access if the herd moved beyond the designated release zone. What emerged was a formal agreement that created something genuinely new in Romanian conservation law, a set of legal wildlife corridors with defined boundaries, monitoring obligations, and a shared governance structure between the Ministry and the X-Force project team. 30 kilometres of corridor, 200,000 hectares of designated movement range, monitoring stations at 12 points across the terrain, equipped with camera traps, acoustic sensors, and automated soil sampling systems feeding data back to the project's central analysis platform in near real time. The monitoring infrastructure alone took 18 months to install. Dr. Elena Petrova, the project's lead ecologist, had designed the sensor network with a specific objective. She did not simply want to track where the bison went. She wanted to measure what happened to the landscape at every point they touched: soil nitrogen levels, canopy gap indices, undergrowth density, seed dispersal patterns, ungulate activity in adjacent zones. The release was designed from the beginning as a controlled ecological experiment, not just a conservation gesture. Petrova had also designed the selection protocol for the 30 individuals making the journey from Polish breeding centres to the Carpathians. This is where the science becomes genuinely fascinating and where the decades of managed breeding programs proved to be something close to irreplaceable. The European bison population had been rebuilt from a founding stock of just 12 individuals, the animals that survived in zoos after the last wild bison was shot in 1927. 12 animals. The entire species, genetically, descended from a group small enough to fit in a single, large room. That founding bottleneck created a vulnerability that breeders had been managing carefully for nearly a century, using stud book records maintained by the European Bison Pedigree Book to track lineage, avoid inbreeding, and maximise retention of what genetic diversity remained. By 2017, roughly 960 animals existed across 10,000 square kilometres of managed and semi-wild range in Europe. The 30 individuals selected for the Carpathian release were chosen using criteria Petrova's team had refined over 2 years. Genetic diversity was the primary filter. Whole genome sequencing identified animals whose inclusion would maximise heterozygosity in the founding herd, reducing the risk of inbreeding depression in subsequent generations. The age-sex ratio was weighted toward reproductively active females with a smaller cohort of young bulls, designed to optimise growth trajectory in the first 5 years. Behavioural health was assessed through structured observation, screening for stress-related suppression or abnormal social dynamics that might compromise integration into a wild-ranging group. 30 individuals, carefully sequenced, carefully balanced, loaded into crates in southern Poland on a morning in early 2025 and driven south toward mountains they had never seen. The number 30 was not arbitrary. It was the minimum viable founding population that Petrova's models indicated could establish a self-sustaining herd within a decade, given the habitat quality of the Retezat release zone and projected mortality rates in the first 2 years. 30 was the number the science said was enough. If the project team had stopped here, this would be a very different story. The planning was exceptional. The infrastructure was real. The science was sound. But planning and execution are not the same thing, and the Carpathians had their own response prepared. Everything the team had built was about to work against them. The crates had been in position since before sunrise, 30 animals, 200 years of absence, and a valley that had no memory of what was coming. Dawn broke cold over the release site, the kind of cold that sits in the low ground and doesn't move until the sun clears the ridge. The team had been on site for hours. The satellite collar signals were already pinging. The camera trap network, 47 units spread across 50 square kilometres, had been live since midnight. Every sensor, every tag, every data feed was running. And then, in the grey-blue light just after first light, the crate doors opened. Nothing happened for a moment. That moment felt long. The first animal stood at the threshold, head low, nostrils working. These were animals born in managed facilities, raised in structured environments, transported across hundreds of kilometres. They had never stood on ground like this, never smelled air like this. The valley stretched ahead, open grassland running toward a tree line, morning mist hanging in the lower hollows. And the bison just stood there, reading it. Then one animal stepped forward. Within 40 minutes, all 30 had moved out into the valley grassland. 40 minutes. That's not a typo. The field team watching from the perimeter described it later as almost disorienting. They had prepared for chaos, for scatter, for animals bolting in separate directions, or refusing to move at all. What they got instead looked, from a distance, almost like routine. Dr. Elena Petrova wrote in her field notes that morning that the animals moved like they remembered the landscape. Purposeful, not lost. That phrase carried weight. These bison had never been here. But 200 years of absence does not erase the deep behavioural architecture shaped across millennia. The valley grassland, the slope aspect, the wind direction, the water sources visible from the release point. The animals were processing all of it, and they were processing it correctly. The GPS ear tags and satellite collars were transmitting real-time ranging data from hour one. Within the first 90 minutes, something in that data caught the team's attention. The bison were not grazing randomly. They were targeting specific patches. When the field team cross-referenced those patches with the vegetation survey maps, the pattern became clear. The animals were preferentially moving toward bramble thickets and invasive shrub clusters, exactly the species that had been suppressing native ground flora for decades in the absence of large herbivore pressure. The monitoring team let the data run through the full first day, then the second, then into the first week, watching whether the pattern held or whether it was coincidence. It held. The grazing pressure was selective in a way that no passive rewilding intervention had achieved in the years prior. The bison weren't just eating, they were editing the landscape according to a logic that predated any human plan for this valley by thousands of years. The real question is what happened behind closed doors, in the data review sessions at the end of those first days, when the science team sat down with the ranging maps and camera trap footage and tried to make sense of what they were seeing. By the end of release day, the 47 camera units had already captured the herd moving through 4 distinct vegetation zones. The footage showed animals pausing at the edges of shrub patches, testing them, then committing. It showed social structure reforming in real time, older animals setting pace, younger ones following. It showed, in one sequence near a stream crossing, a single bison standing in shallow water for several minutes before the rest of the herd approached. The team had expected the animals to need time to orient. They had built buffer protocols around that assumption. What the data showed instead was a herd that arrived knowing something, not in any mystical sense. In the plain biological sense that behavioural templates encoded across hundreds of thousands of years of Carpathian evolution had not been erased by 2 centuries of managed absence. The landscape matched the template. The animals responded to it. By the end of the first week, the ranging data showed the herd covering ground in a pattern that aligned closely with the pre-mapped high-value grazing corridors identified during site assessment. Not perfectly, but closely enough that the lead ecologist later said the animals had essentially validated the habitat model independently, without being guided toward it. 30 animals, 50 square kilometres of instrumented release zone, real-time data from collar to screen, and a herd that moved on the first morning like it had somewhere specific to be. Spring 2025. The Carpathians. The herd was still moving. There is a version of this story that ends with a graph. Herd cohesion metrics, ranging area in square kilometres, dung deposition rates near water sources as an early signal of soil enrichment beginning to build. Camera trap images from April and May 2025 showing red deer approaching the clearings the bison had opened in the bramble, stepping into spaces that hadn't existed 6 months before. All of that is real. All of that matters. But the version worth sitting with is quieter than that. By late spring, the herd was ranging across approximately 60 square kilometres, still cohesive, no significant dispersal, no conflict incidents in the surrounding communities in the first 6 months. The liaison protocols were holding. The valley was doing what the valley was supposed to do, and the team that had spent years building toward this moment was, in a meaningful sense, no longer the most important thing happening in that landscape. Think back to that cold open, that morning, the crates, the mist, the animal at the threshold reading the air. What that moment contained was not a triumph of planning. It was a question being asked of the landscape, and the landscape answering. Recovery is not a human act. It is a process we can obstruct, or we can step back from. The bison didn't need the valley explained to them. They needed the valley returned to them. And the data from those first weeks, the selective grazing, the purposeful movement, the soil signals beginning to accumulate near the water sources, all of it pointed to the same quiet conclusion. We didn't restore the valley. We returned the animal that knew how and then got out of its way. A silver fir seedling reaching light it hadn't touched in 2 centuries,